Today I want to show you a tool called Miller. So oftentimes when we want to integrate two systems, we're going to use CSV files because CSV files are one of those things that are very common. Every single language has a library for processing CSV files. But oftentimes in the process of using CSV files, we need to do some one-off operations. So for example, maybe we need to sort a column, maybe we need to change the delimiter, maybe we need to convert from CSV to JSON, maybe we need to remove certain records, maybe we need to add certain columns. So usually when I have these types of problems, what I will do is I will create a one-off Python script. But the problem is that this Python script often has bugs because it's my first time writing that code, for example, against that file. So I would very much prefer if there was some kind of battle-tested tool for processing these CSV files in these common use cases. So I found such a tool, and it's called Miller, Miller. I have a file here called data.csv, and data.csv looks something like this. Okay, so let's have a look at the columns. Okay, and what we're going to do during this video is that we're going to go through a few scenarios of using Miller to process this CSV file. Okay, so when you use Miller, the commands or the operations that are exposed in Miller are exposed in what they call verbs. So verbs that exist in Miller include things like cat, put, filter, cut, and sort. And they have a lot more. In fact, the documentation is very extensive. But for those cases where it's overkill to write Python scripts, I'm going to show you how Miller can help. Okay, so let's have a look at one simple scenario first. Okay, the first scenario that I want to show you is pretty printing this CSV file. So as you can see, the CSV file is not very readable, right? We cannot easily tell which values correspond to which columns. So it would be cool if we could pretty print the data. Okay, so the way to do that is I'm going to specify that the input type, and the way that you specify the input type is you put I and then the type of the file. So in this case, it's input CSV. And what I want to do is I want to print the output in pretty print. So I do O print. So output pretty print. Okay. So then I use the cat verb, right? And then the input for this for Miller would be the CSV file. So it's data.csv. Okay. There. So now it pretty prints the data. Um, let's say that we want to convert our file from JSON from CSV to JSON. So we can do that by using a similar command. So we do iCSV, which because our input is CSV, and we say O JSON. Okay, so we do cat data.csv. Okay, and now the data is JSON. Okay, sorry, I made a mistake just now. I forgot to put the dash. Right. So now you see that it's JSON. Okay, but if you notice, it didn't wrap the JSON output in an array, right? So if you want to wrap the JSON output in array, you would, sorry, let me repeat that command. So it doesn't repeat the JSON output in a command in a array. So in order to wrap it in an array, we just need to add one more parameter, which is JList wrap. Okay, and when we do this, oh, sorry, I misspelled that. When we do this, you'll see that it puts the array character in the beginning. Okay, right. So another use case that I want to show you is sometimes, as you notice in our file here, the values are separated by commas, right? So sometimes we need to convert from comma separated to pipe separated or tab separated or semicolon or whatever separated values. So to do that in Miller is very simple. You just do MLR. and then you specify the field separator. So in this case, we specify the O because it's the output, and we specify FS, which stands for field separator. Okay, and in this case, we want the output field separator to be the pipe character, and we want both input and output to be CSV. So we just do CSV without the I or the O, and then we do cat data.csv. Okay, and as you can see now, it's pipe separated. Okay. Another thing that's quite common for us to do is that we want to remove columns. So for example, maybe one system is producing 10 columns, but the other system only needs 5 of them, for example. Okay, so let's have a look at our file again. So as you can see, we have quite a lot of columns here, but for our further analysis, we don't need most of these. Okay, so we don't need, for example, inflow, we don't need flag, we don't need memo, we don't need category, group, we don't need category, group, category. Okay. So to remove that, there's a verb in Miller called cut. So what we do is we just specify the columns that we want to cut. Okay, so let's do Miller CSV, and then we do cut dash x dash f. So f are the fields that we want to remove because we specify the dash x. So we do inflow, flag, memo, category group, category group. Okay, so we want to remove these columns. Okay, and we specify the input, which is data.csv. Okay. Right, so now we only have, okay, let's do head again here. So now we only have 1, 2, 3, 4, 5. We only have 5 columns now. Okay, now by default, the output of that command will go to standard output, right? So what if we want to edit the file in place? So the way do we do that is we'll run the same command again, but we want to perform this edit in place. That means we want to edit the file data.csv. Okay, so the way we do that is by specifying the -I option. Okay, so now if we look at the data.csv, we see that it's been edited in place. Okay, so what I really want to do is I want to actually use Miller to perform some numerical operations. Okay, that means you see that there are these this column with numbers, right? But the problem is that this is not a number, right? Because it has a $sign, right? So it's difficult for me to perform numerical operations unless I remove that $sign, right? So what I'm going to do is I'm going to make use of the put verb. So the put verb's purpose is to add or remove columns or update column values. So in this case, what I want to do is I want to update the value of the outflow column so that it has the value but minus the $sign. Okay, so the way I do that in Miller is, okay, so I'm going to do this in place because I want to make use of the edit after this, and then CSV because I want both input and output to be CSV. Then I use a put verb, and the thing about the put verb is that it supports kind of like a micro language, a domain specific language. So in this domain specific language, you can refer to the fields of the record by just using $sign, the name of the field. So in this case, the last column here is outflow, right? So if I want to refer to that value or update that value, I just do $sign outflow. Okay, so that's how I refer to the value of that column. Okay, then there's a function in that DSL called string substitution. So it's just s sub, and then what I do is I take the original value outflow, right, and then I want to remove any $signs in that value. Okay, so okay, just in case we make a mistake, let me just remove the I operation first so that we see it in action. Then we put a, how can I keep this? Okay, so then we put a semicolon, and we put this, and we put data.csv. Okay, so let's put head so that we can see the first few columns, and there. So as you can see now, the operations don't, now the outflow column does not have any $sign. Okay, so let me run the same command, but let's do it in place so that we update the file so that we can use the resulting file in future commands. Okay. So now let's just double check that the data is correct. And there, okay, that's what we're expecting. Okay. The second thing that I want to show you is one of the common things that we want to do with CSV files is that sometimes we only want a subset of the data. So as you can see, there's a category field here, right? So the categories that I have are things like electricity, groceries, rental, water bill, for example. So let's say that I am only interested in, I think I made a mistake in the operation where I did the cut. So let me just revert that for a second. Okay, so cp data original cp data.csv. Okay, and let me just run the cut command again. Okay, so where's my cut command? I think I made a mistake with the cut command. Ah, yes. So I didn't mean to remove category. I meant to reduce group category. Sorry about that. So I meant to remove category group. So I made a mistake there. Category group. Okay. So let's remove the category group data. And now let's look at data.csv again. So head data.csv. Okay, now there's a category column here because I accidentally removed the wrong column. Let's run the transformation again for removing the dollar sign. So where's that? Okay, here, remove the dollar sign. And let's have a look at data.csv now. Okay, great. This is exactly what I want. Okay, so what I want to do is I want to filter the data here by category. Okay, so in this case, let's say that we only want to see records where category is equal to electricity. Okay, so the way you do that is using the verb filter. So Miller CSV, and then we do filter. Filter is the verb. And again, we can use the same DSL. Okay, so the DSL in Miller is available to only two of the verbs, the put verb and the filter verb. So what we do is we just when we want to filter, we just specify a Boolean condition by writing DSL code. Okay, so in this case, we say we want category, the value of category, right? Remember, I said that we can refer to the value of the field by just placing the dollar sign in front of the field name, right? So dollar category is equal to electricity. Okay, so that's the logical operator, right? So electricity and data.csv. Okay, so now we should only see records where category is equal to electricity. Okay, there, right? So what's cool is in Miller, just like with using shell scripts, we can actually chain verbs together, right? So let's say that I want to filter by category, and I also only want to show the category and the outflow columns, right? So what I can do is I can chain the filter verb with the cut verb. And the way this is done is using the then keyword. So let's run the previous command again, but we'll add a then cut, and we only want to see a few fields, which is category and outflow. Okay. So then we simplify data.csv. Okay. So what it will do is that it will filter by category first, then the results, it will remove all fields except for the category and the outflow fields. Okay, there. Okay, so it becomes a lot more readable now. Okay. Another thing that I want to do, okay, let's look back at our data file, is that I want to be able to do some statistics based on month. But as you can see, the date column here is comprises of the month, date, and day and year, right? So what I want to do is I want to create an additional column which contains the month that that transaction was took place in. Okay, so the way I do that is, okay, we'll do this in place of this, but I just want to make sure that the command is correct. So we use the put command, right? Because the put verb is for updating or creating new columns, right? So the way that we create a new column is that we just imagine that it already exists, and we set the value accordingly. Okay. So what we do is, what we want to do is we want to split the date column, right? So date by the separator, right? Date, all right? And then what we'll do is we set the month to be, okay, so we'll create a month column. Okay, so we just, we just set the name of the column, and then, the variable name to the name of the column that we want, right? So in this case, we want the name of the column to be month. So we just prefix that with the $sign, right? So we do month is equal to T1, and then we put the year plus the year. So as you can see in their DSL, their operator for concatenating strings is that dot operator. Okay, so let's see what happens if I run this. Okay. Yeah, so as you can see, it created this. Let's put head so that we can see it. So as you can see, it created this additional month column, and it has the month and the year in it. Okay, so we can easily do group by operations. Okay, so let's run this command again, but let's do it in place so that we can use that column in future operations. Okay, one other thing that Miller can do is that it can help us with some common arithmetic, or numerical operations. Like for example, it can help us with calculating the average, or group by sum, or count, group by count, for example. Okay. So the way this is done is using the stats1 verb. Okay. So let's say that we want to see a breakdown of all the payees in all the payees based on the number of transactions that occurred against with that payee, right? So if, for example, I went to supermarket A 20 times, I should see supermarket A and then 20. Okay, so the way we do that is very similar to SQL, where you do a count asterisk group by the payee, right? So the way we do it is very similar in Miller. What we do is you do Miller ICSV, because our output is ICSV, and because we want the output to be for human consumption, so we specify O preprint, right? And we use the stats1 verb, and we specify the arithmetic operation that we want, which in this case is just count, and we specify the column that we want to count, as well as the what we want to group by. So in this case, we want to group by A. Okay, so let's see the output. Okay, so let's head that so that we see the column, we see the header. So when we do this, it will automatically create a column with the name of the column that was being analyzed, and the statistic that we want to create. Okay, so this is not that useful because we cannot, the column here is not sorted, right? So what we can do is we can chain this command with the sort command, with the sort verb, so that we can see which pays I transacted with the most. Okay, so let's do sort, then sort dash nr pay count. Okay. Okay, so let's just use head again so that we see the the top output. So there we can see that the payees that I transacted with the most is supermarket A and supermarket B. What I want to do first is I actually want to calculate for the whole file. Let's first calculate for the whole file how much I spent at each grocery store. Okay, so first of all, we need to filter filter the grocery stores, right? So let's do filter And of course, we can use a DSL here, and we do groceries. Okay, so we only see records where category is equal to groceries. Okay, then what I want to do is I want to sum it up. So what I do is I do stats1 a sum, and I want to sum up the outflow column, right? So I do outflow, let's just do that. And I want to group by the pay. So I know how much per pay I'm paying in groceries. Okay. All right. So as you can see, supermarket A, I spent almost $5,000 there. Okay. And in supermarket B, I almost spent 4,000. Okay. Um, okay. So now, what if we want to break this down further, and we want to see the breakdown by month and grocery store? So what I can do then is I can, instead of just grouping by the payee, I can group by the month and the payee. So I just do group, and I do month, comma, pay. All right. So now we see the breakdown based on month as well as the pay. Okay. So in July of 2020, I spent um, I spent $11 at this pharmacy. I spent 533 at this supermarket, and I spent $170 at this other supermarket. Okay. So I only scratched the surface of what Miller can do. It can do so much more. But the thing is, the DSL is a full-blown language. But once once we start doing more and more complicated things in the DSL, right? If we're just using the other verbs, or we're using a small subset of the DSL, then it's fine. But once we start doing much more complicated things in the DSL, then I think it's much better if we just use Python. Okay, but for these common one-off operations, I think Miller is such a great tool, because if I were to write that same code in Python, I would need to debug it. I may have made like a typo, or I may not. I may have used the CSV library wrongly, right? Because there are issues with the Python CSV library, right? So that's about it that I want to show. Just remember, Miller is great for these one-off, very simple operations. But once you find yourself needing more and more complicated things, and you start looking at a DSL, you might want to consider using a proper Python script. Okay, thank you very much.